So what is the theory of games? It is a mathematical theory which deals with the general features of the competitive situations, right? So this word is very, very important. When we have a competitive situation, it may be between two individuals or the organizations, and when such situations are there which are competitive in this nature, this mathematical theory explains that competitive situations and helps in understanding how the profits can be maximized or the losses can be minimized, right? So it is of that philosophy, right? So again, the same thing, that is, it is helpful when two individuals or the organizations with conflicting objectives try to make a decision, right? So there will be always no, more than one individual or the organizations which are competing with each other, and what is their what is their objective, what we can say, is to try to make the decisions, right? Now, in the due course of the explanation, few more points will come. But when you are trying to make a decision, you take lot of care. You think of lot of ifs and buts. You think of what other may take as a decision, and then you prepare for that particular decision. Even in many cases, you also prepare for a scenario. If the other individual taking this decision, I'll be taking this decision, or if he is going to take this decision, my decision is going to change, or it is going to remain same. So there can be different strategies that you can develop as an individual or as an organization while taking the decision. So your decisions may be dependent upon the others' decision, or your decision can be an isolated decision, irrespective of the decision that the other organization or an organizations are making, right? So your discussion made by one discussion maker, but when we are going to see about the game theory, we are always going to have this assumption or have this understanding with us, right? And what is that understanding, which is very, very important? Here, decision made by one decision maker affects the decision made by one or more decision makers, and the final outcome depends upon the decision of all the parties, right? So here, what is going to happen is that everyone is going to make certain decision, right? One person is making any decision, that doesn't mean that the other person is not going to make a decision. All the stakeholders or all the players are going to make a certain decision, and the decision of one player is going to affect the decision of the other player, and the decision of the other player is going to affect the decision of different players after him. So those decisions are going to be made by every player, and the no lastly what will be there, there will be certain outcome, and the final outcome will be what, it will be depending upon the decision of all the parties or all the players, right? I'm hoping that no you are understanding this, how this is working. So there are two, more than one organization or an individual who is trying to make any decision, right? And the decision made by one person or one player is going to affect the decision made by the other players as well, and the final outcome of the decision will depend, or the final outcome of that particular play will depend upon the decision of all the parties. This is very, very important, and the basic no you can say this is the basic assumption of your game series as well. So where does it has an application? It has applications in business, in industries, in economics, in the sociology, and the military training as well. So this the list is this is not an exhaustive list. It particularly can many more applications can be added into it, and the list is particularly you can broaden the list for this game theory application as well. Right. So this works on what is the principle that it is working upon? It is a minimax principle or a max mini principle. So that we are going to see when we are going to see the numericals, as well as in the due course of the explanation ahead. This will come. But as of now, you can understand. It is here. It is minimization of it is particularly. Um, it will be dealing with the minimization of the losses for few of the players, and it will be related with the maximization of the profit with few of the players, right? So it is based on the minimax principle by John von Neumann, which implies that each competitor will try to minimize his maximum loss or maximize his minimum gain, or achieve best of the worst. So this is very very important. So what it minimax principle applies that every player or every contributor is trying to minimize his maximum loss, right? So player considers now what is my maximum loss, and he's trying to minimize this particular maximum loss, right? Or what we can say, a particular player what is knows what is his minimum gain, and what he is doing is maximizing his minimum gain, right? So what is this? This is achieving best of the worst, right? So what is the worst case scenario? Worst scenario is having to have a maximum loss. The worst case scenario is having a maximum loss. But what is best of the worst is to try to to try to minimize his maximum loss is nothing but achieving the best of the worst. Similarly, in the other strategy, what is the what is the worst thing that can happen, that the you are getting a minimum gain. But what is the achieving best of the worst is maximizing the minimum gain, that is achieving best of the worst, right? So this is the principle which is also called as the minimax principle. It is developed by John von Neumann, and the principle is very very interesting and very easy to understand as well, right? So the theory doesn't describe how a game should be played. It describes only the procedures and the principles by which the plays should be selected. Plays is the every step that should be selected. The theory doesn't describe, it is very important, it doesn't describe how the game should be played, right? ये नहीं बोलेगा कि इसके बाद ये स्टेप करो वो स्टेप करो, नहीं. It describes only the procedures and the principles by which the plays should be selected, right? So this theory has been capable of analyzing very simple situations, and hence the wide gap in its application part. So this is one of the drawback of it, right? So no, particularly for some simple situations, and also for some of the complex situations, you can use this theory for the analyzing purpose. But again, when we have to apply it on the larger scale, particularly it has a less application part. So this is, you can say, one of the disadvantage of this games theory, right? So next, what we are going to see is what are the characteristics of these games, right? So there are finite number of participants or the competitors, and if number of participants are two, then the game is called as a two-person game, and for a number of participants greater than two, it is called as a n-person game. But this n is not it is not depending upon, like if there are three-person, you can't say that it is a three-person game. So this n is representing the number of strategies that the player can play. So that will come in the due course of time. But as of now, preliminary, you can say that there are finite number of the competitors. You cannot say that the number of competitors or the participants or the players are infinite. You should know how many are the player. Each participant should know how many players his or how many participants he is competing with, right? So the number of the participants are finite. If it is a two-participant game, then it is called as a two-person game. And for the greater than two, no, it is called as the n-person game. But here n is nothing but the number of strategies, right? So each participant has available to him list of the finite number of the possible courses of the action. The list may not be same for each of the participant, right? So every participant has no available to him list of the finite number of the possible courses of action. For example, this no, there are each participant will have 5 actions, finite number of actions. So action A, action B, action C, action D, and action E, and he has to select proper action depending upon what his other participants have selected. Right So the list may not be same for each of the participant, right? So this is very obvious. So every participant will have his own list, and the other point is interesting. So each participant knows the possible choices available to others, but does not know which of them is going to be chosen by them. So if a two-person game and I am playing with the other, so I know that that particular participant is having what possible choices, but I don't know when he is going to select any one of them and particularly throw upon me, right? So that is the beauty of this. So each participant is, this should be thought in the combination. So each of the participant is having his own list of actions, right? And is also aware of what is the actions that the other participant is going to take, but he is not aware when when the other participant is going to choose which action, right? So other particular other participants actions are known, but their timings are not known, right? So a play is said to occur when each of the participant chooses one of the courses of the action available to him. The choices are assumed to be made simultaneously so that no participant knows the choices made by others until he has decided his own. So this is again the one of the considerations here. So a play, when we say that no, the play has said to occur, that one of the each of the participant chooses his one course of action. So after choosing, we say that the play has occurred, and the choices are to be made simultaneously, right? So it is not particularly made simultaneously, so that no participant knows the choices made by the others until he has decided his own, right? So that is again important. Every combination of courses of action, so here the choices are made simultaneously, right? So the choices are made simultaneously, one at a no, all will be choosing their course of action at a single time, right? But when I say that each person participant action, particularly what was it there? So we have seen in the particularly here, where was that? Okay, so decision made by one decision maker will affect the decision made by one or more decision makers. So that is how particularly after every play they have a choice in other the next play which action is to be chosen. एक प्ले में जब होता है तब सब अपना जो डिसीजन है वो एक साथ ही हम लोग क्या करते हैं, कन्वे करते हैं, ठीक है? तो सेम प्ले में उसके particularly there are no choices, you have to decide your decision, and every decision everyone will be telling at same time. But now in the next play you can particularly think of no particularly different decision depending upon the decisions made by the other players. So that is particularly available in the next play. So every combination of the courses of the action, so after every play there will be certain outcome, right? And the outcome will be the gains for a few and the losses for the few, right? So every combination of courses of action determines an outcome which results in the gains of the participant. So when I've written only a gain, why? Particularly a gain can be a positive, negative, or zero. Negative gain means that it is called as the loss. So particularly few of the participants may get lost, few of the participants may get no uh, uh, what we can say, few of the participants may get profit. So or there can be neither profit nor no neither profit nor the loss to any of the participant, it may remain zero, right? So particularly that can happen, right? So now the gain depends not only on action of the participant but it also on the others action, right? So it is very very अपने खुद के एक्शन के नहीं, पर बाकी लोग भी क्या एक्शन ले रहे हैं उसके ऊपर मुझे प्रॉफिट होने वाला है या लॉस होने वाला है, या मेरा जो टोटल टैली है वो जीरो रहने वाला है, दैट विल बी डिपेंडेंट. The gains for each and every play are fixed and specified in advance and are known to each player. Thus, player knows fully the information of the playoff matrix. So here, playoff matrix is given. What is the playoff matrix? तो अगर किसी ने ये कोई ए डिसीजन ले रहा है, कोई बी डिसीजन ले रहा है, तो ए डिसीजन लेने के बाद उसको कितना फायदा होगा ये सबको पहले से ही मालूम है। बी डिसीजन लेने के बाद कितना फायदा होगा वो सबको पहले से ही मालूम है। तो खुद का भी मालूम है और दूसरे का भी मालूम है, right? So this is called as the playoff matrix, right? So the playoff matrix of no, it is known to everyone and it is fixed and specified in advance, right? So everyone is knowing, no, going knowing that what he is going to gain after playing this step, as well as what others are going to gain if they are playing their respective steps, right? तो ये सबको पता है. So the player make individual decision without no, there is any direct commission. There is no, particularly he is going to make his individual decision. That is the gist of this, right? Now there are various game models as well. So various game models depending upon the factors like how many number of players are participating, what are the sum of the gains and the losses, and the number of strategies that are available, etc. are constructed. So for example, the depending upon the number of person, right? So if there are two players, we have already said it is a two-person game. So if there are more than two person, it is the n-person game. So what is the n-person game? N n player doesn't imply that there are n players, right? So it implies the player can be classified into n mutual exclusive groups with all members in the group having the identical interest, right? So this is particularly depending upon the classification of the n mutually exclusive groups. For example, few of the participants are on particularly what we can say are playing to make any decision to happen, and few are playing to oppose that particular decision. So there are two groups that are particularly happened. So these two groups happen. No, this and suggests that there are these two groups, right? So no, if there are three, no, if there are three choices, and the players are been can be divided into that particularly which player is going to take which choice. So there particularly you can define there are three groups, and these three exclusive groups particularly the value of that n will be 3, right? So the groups of the identical interest are made, and how many number of groups are there, that is nothing but your value of n, right here. So we can say that it is a two-player game, it can be a three-player game, but when we say that it is a three-player, it suggests that there are three groups. In two also, no, one will be playing for one decision and other will be playing for the other decision. So there are two groups here, so that is two-person game. If there are more three groups and the three groups are representing particularly every group is representing some identical interest, so the game can be called as the n three-person game. Sum of the payoffs, right? So if the sum of the payoffs to the player is 0, then the game is called as the zero sum or a constant sum. Otherwise, it is called as the constant sum or a zero sum, right? So when particularly when there is a payoff, and when this payoff is 0, for example, a player is earning rupees 4 and the other player is earning -4. So 4 plus -4 is what it is equal to 0. So that particularly suggests that the payoff is coming out to be 0, and hence this particular game is called as the zero sum or a constant sum game. If it is not happening, then it is called as the non-zero sum game. So we are going to see it in the numerical part when particularly we are going to suggest when we are going to use this models. So that particular time I'll be telling you, right? So number of strategies again. So if I'm having the finite number of strategies, it is called as the finite game, and if it is having the infinite number of strategies, it is called as the infinite game. So right. So we have classified our models into three main groups. That is like number of person अगर है तो two players होगा तो two person. अगर तीन से ज्यादा सेम इंटरेस्ट वाले ग्रुप है या दो से ज्यादा सेम इंटरेस्ट वाले ग्रुप है तो वो n that you should give that value of number of groups to this n. Some of the payoffs, it can be a zero sum game or it can be a non-zero sum game. Number of strategies, it can be a finite strategy game and it can be an infinite strategy uh, game, right? So let's take a few of the uh, uh, what we can, let's consider a few of the definitions, right? So what we have is a game. What is the meaning of or the definition of a game? An activity between two or more persons involving actions by each one of them according to the set of rules which result in some game, which can be positive, negative, or zero for each, is called as a game. So what is a game? It is an activity between two or more persons involving actions by each one of them according to the set of rules, and which will result in some gain, which can be a positive gain, negative gain, or a zero gain. It is called as a, particularly this course of action is called as a game. If a game is determined by the skills, it is called as the game of a strategy. So if there are strategies that are particularly defined for every player, so it is called as the game of a strategy, right? And if there are no strategy, every particularly the players are depending upon the chances, right? So it is called as the game of a chance, or you can say no, they are depending upon the luck, right? So it is a game of a chance. So your chance means that it is a luck, right? So if a game is determined by skills, so it is a game of a strategy. So when we are going to focus on the the games which are depending upon the strategies, and no, particularly if there are games which are where the player is selecting, he is having no strategy and he is playing by chance, then it is called as the game of a chance. A game can be a finite or infinite. No, so finite can be, no, the particularly there are finite moves and the choices, same as the finite strategies. And if it can be an infinite, so that there are infinite moves and the choices. That means that it is there, the game is having the infinite number of strategies, right? So what is a player? Each participant or a competitor playing in a game is called as a player. Each player is equally intelligent and rational in approach, right? So there is no player who is having less intelligence, or particularly is having more dominance, or who is and everyone is thinking rationally, right? So they are thinking of all the possible choices and then they are taking the decision, right? So the game is played rationally and not partially, right? So no one is doing any no, particularly no one is going to do any favor to other, right? So they are playing it rationally. What is a play? A play of a game is said to occur when each player chooses one of his courses of action. Now, for a particular game, there can be number of plays. Plays are nothing but the steps, right? So there can be number of plays in a particular game. So when we say a play is happen, a play of a game is said to occur when each of the player chooses one of his courses of action, and at that time we say that there is a play that has happened, and there can be several plays in a particular game. All right. So what is a strategy? It is a predetermined rule by which a player decides his course of action from his list of courses of actions during the game. To decide the particular strategy, the player need not know the other's strategy. Very, very, very important, right? So what is a strategy? It is a predetermined rule by which the player will decide his own course of action amongst the various courses of actions in his list, right? And no, he'll be doing it in rational manner, and no, particularly he does when he's taking any decision, he does not know what other player is going to, what other player's strategy will be. He's going to decide his own strategy, right? Now, we have next definition, which is a two-person zero-sum game, right? So it is just an explanation where we have a two-person zero-sum game. We have already seen what is a two-person game. We have already seen what is a zero-sum game, and now we are going to combine this particular two things, terminologies. So it involves two players only, in which the gain or the gain of one player equals to the loss of the other. So when we say that there is a zero sum game, so one of the, I've already given the example. So the gain of one of the player was +4 and the gain was -4. So +4 -4 is equal to 0. So that is the gain of one player equals to the loss of the other. So I'm winning 4 rupees and other is losing the 4 rupees. So what is that particular thing? That is nothing but the zero sum game. The same sum of this particular winning or the gains is 0. So it is also called a rectangular game or matrix game because the play of matrix in this particular form will be a no, it will be a rectangular matrix. So because of that, it is also called as a rectangular, particularly game. Now, characteristics of what are the characteristics of a two-person zero game? So there are only two players that are involved. You have finite choices, right? So finite choices are there. No, the specific strategy to result which result into a payoff is already known, and the total payoff to the two players at the end of the particularly it will be equal to 0. So there will be neither gain to any player, neither it will be loss to any player, and no, hence it is called as a zero sum game that has been given to us. Right now, the next step that we are going to next definition that we are going to see is related with the payoff. Right. So what is a payoff? It is the outcome of the game. Right. So something I will be getting something. Right. So it will be the gain that we are going to get from that particular no this thing. So when I say that I am going to have a rupees 4 no gain, so what is that 4? 4 is nothing but payoff. In the same sense, the other person is going to lose that particular 4 rupees. So it is also said as payoff, but it will be when it is losing. So we say that it is no -4. When we are gaining or when we are receiving, we say it as a +4. So it is the outcome of the game. Payoff matrix is a table showing the now what we have here is the payoff matrix they are talking about. There's a table showing the amounts received by the player named at the left hand side after all possible plays of the game. The payment is made by the player named at the top of the table. So to explain this particular what is the payoff matrix, so I've taken an no, particularly an examples are also there, right? So this is an example here. So let's no particularly think of this. Let this player A has M courses of action and B has n courses of action. तो प्लेयर ए के पास कितना है ए कोर्सेस ऑफ एम कोर्सेस ऑफ एक्शन है और प्लेयर बी के पास कितना एक्शन है एन कोर्सेस ऑफ एक्शन है. Then the game can be particularly described by a pair of matrices which can be constructed as below. Row designations, right? So the row designations for each of the matrix are the courses of the action for A, right? So A के actions जो भी है, all these are represented in this particular row, which is depending on this particular. So row designations for each of the matrix are the courses of the action available to the matrix A. Now let's focus on this. This is player A, and how many courses of action he has into his list, starting from M to starting from 1 to M. So we have already said this. See, M are the courses of the action for A. Similarly, this is player B, and how many courses of action does he have? He has n courses of action. So starting from here we have, so B has n courses of action. So starting from 1, so he has n courses of action with us, right? So particularly now this is a payoff matrix, right? So the cell entries are the payments to A for one matrix, for one matrix, and to B for the other matrix. So now particularly think of only this one matrix. No, the cell entry Aij is the payment to A in the A's payoff matrix, right? तो अभी ये जो मैंने A11 लिखा है, A12 लिखा है, A13 लिखा है, Aij लिखा है, तो ये क्या है? ये सब पेमेंट्स है particularly that these A is going to get received, right? So if A11 is having a positive value, that means that he is gaining that particular thing, right? If A12 is having a negative sign, that means that he is losing that particular thing. Who is losing? Now this is the payoff this is the payoff matrix for which player? It is the payoff matrix for player A. So everything, every value that has been represented in this matrix is with respect to player A. So if he is gaining anything, the value of all these, the values of Aij will be positive. If he is losing anything, so the values will be negative, right? So here, what is this? Let's say that when the player A is selecting this course of action, and for that course of action, player B has selected this course of action, and if this value is positive, that means that player B will pay something to player A, or what we can say, player A is going to gain something, right? Now, for example, player A has selected this course of action and player B has selected this course of action, and the value of A33 is coming out to be negative. That means that player A is going to lose something. So when something is to be lost, someone is going to get, someone is going to get gain. But now, as this is a payoff matrix for player A, so the loss of his will be represented negative, while the loss of his will be represented as positive, right? So this